Hello everyone. Today we will be discussing the post-contest analysis of Codeforces Round 1006 Division 3. In this session, we will be going over the first 5 problems and break them down step by step. So without further ado, let's dive into the very first problem of this contest, and the problem name is New World, New Me and New Array. Let me read the problem statement. Natsumi Akaito has just woken up in a new world and immediately received his first quest. The system provided with an array of n zeros and integer k and integer p. Okay. So in one operation, Akaito chooses integer I and x such that I is less than n, and we are provided with x range minus p to p, and we can perform the assignment ai is equals to x. We can help him calculate the minimum number of operation required to make the sum of elements in the array equal to k, or tell them it is impossible. If it is impossible, we have to return -1. Okay, so let me explain the problem statement first. Let me just copy this and paste it here. So we are given n, k and p. Okay, we are given array of n integers. Like, I can take smaller input so we can understand it better. K is equals to 30 and P is equals to 10. Okay. Yes. Now my array of n integers is 5. 3, 4, 5. Initially it is completely filled with zeros. Okay. So we have to make the array sum equal to k. Okay. We can assign each element to x. ai is equals to x. Okay. Now we are given x range. X range can be minus p to p. Okay. X can lies in this range minus p to p. Okay. So we have to make the sum equal to k. I think the problem statement is clear to everyone. Now let's move to the solution. Okay. So in order to solve this problem, first we have to understand the -1 part. What is the test case when the answer is -1? Okay. So if my n is equals to 5, yes, and our x range is minus p to p. What is the maximum sum I can obtain by choosing x? Okay. So what is the maximum sum I can obtain? I can assign p to each index. Okay. P, P, P. Then my array sum is 5 into p. This is the maximum sum I can obtain. Okay. Now, I think that what is the minimum sum I can obtain? 1, 2, 3, 4, 5, and the minimum sum I can obtain by choosing x is minus p. Okay, because minus p is optimal to select. Minus p, minus p. Yes. So my array sum is minus 5 into p. Now we will conclude that if my k is lies in this range minus 5p to 5p, then the answer is possible, otherwise my answer is not possible. I think this much is clear to everyone. uh, there is no need to further explain this part. Okay, so my answer is -1 if my case doesn't lies in this range. Okay, so now we calculate minimum number of operation to achieve final sum. Okay, so to achieve this, let's take the example for this. Okay, example is n is equals to 5 and k is equals to 30, and our p is 7. Okay, so we have 5 dashes. We have 5 length of array. Okay, initially filled with zeros. Okay, so to achieve 30, the maximum I can assign to each index is 7. So I will assign 7, 7, 7, 7 3 is a 21, and 7 4 is a 28. So for the last option, I will assign 2. Okay, yes, that's the main crux of this problem. Like, I can divide 30 by 7. It will give me a 7 4. 7 4 is a 28. Okay, so the remaining is 30 minus 28 is 2. I can assign 2 to this index. Yes, for the positive one, for the negative one is also the same. Okay, so if I take minus 30 and 7, it will remain same because I can assign each index with minus 7, minus 7, minus 7, and at the end I can assign minus 2. Okay, so I think the solution is clear to everyone. Let me show you the code, it will be much better. Yes, come on, just a second guys. Yes, that's it. Okay, so we will take input nkp. I will assign a range minus n into p and maximum range n into p. Okay, so if k is in between this range, then the answer exists, otherwise answer is minus 1. Okay, so I will try to assign each index with k, with p. Okay, with p I will try to assign each index to p value. If the remaining element, if uh, if after assigning each value to p, if it is remain at the end, then I will increment element by 1. So I will then print the answer, print the element. Okay, so yes, that's the first problem of this contest. Now we are going to solve the second problem of this contest, and the problem name is, having been a treasure in the past, I help goblins deceive. Okay, let me just open this. Okay, first I will read the problem statement. Okay, so since Akaito had no nowhere to live, he wanted to find out the price of housing. It is well known that goblins write numbers as a string of characters, this and this, and the value represented by the string s is the number of distinct subsequences of the string that are equal to this string. Okay, now we are given an example. So we have to maximize the occurrences of this string in our string. Okay, so let me just explain this problem statement. So we are provided with this type of string, which is initially this. Okay, now in our main string we have to maximize the occurrences of this string. Let's call this string is equals to s. Okay, let's call this string is equals to s. We have to maximize s string occurrences in our t string. Okay, we have to maximize the s string subsequences in t string. Okay, like if my string is look like this, t, we have to maximize the occurrences like one, this this is the first occurrences, this is the second occurrences, this is the third occurrence, this is the fourth occurrence. Okay, so we have to maximize the occurrences of this string in our t string. Okay, so I hope the problem statement is clear to everyone. Okay, let's move to the solution. So for solution, let's think of a base case. First I will assign upper is equals to this in this character. Okay, I will assign lower to this character. Okay, so if I say upper, it means this, I am representing this character. If I say lower, it means I will representing this character. Okay, so let's think of a base case. When the answer is 0, we need uh, we need to maximize the subsequences of upper, lower, and upper. Okay, in this t string. Okay, so my answer is 0 if my upper is less than 2, if my upper is less than 2, and lower is less than 1, less than 1. Okay, then the my answer is 0. Okay, I think this much is clear to everyone. Okay, so when the answer is my equal to 1. Okay. If my upper is 2, if my upper is 2, this and this is 2, count value of 2, and lower is 1, then I have only one subsequences of this string in T. Okay, I can rearrange these elements so uh, we can only have one occurrences. Then my answer is 1. Okay, now we have to do further. Like 0 case clear, first case is clear. Okay, now I have to make upper, lower, and upper. If I will assign one upper to first index and second upper to last index, and assign all the lower values to this in between first and last, it will give me an optimal solution. Why it will give me an optimal solution? Because see, if I will draw this, it will give me a 1 occurrences, 2 occurrence, 3 occurrence, 4, 5, and 6, 7, like that. So it is optimal to select for first index to be the upper and last index to be the upper. Okay, and in between we filled with zeros. Okay, so I think this much is clear to everyone. We have to assign first and last to be the upper, and in between we have to assign the lower values. Okay, so what about the rest of the upper values? Okay, so now my upper values is 4, and lower is 7. Okay, okay. Now uh, now my upper value is 4, which is my first and last is assigned with. Now my first and last assigned with upper. The rest of the upper I assigned with uh, adjacent to the first and adjacent to the last. It will give me an optimal answer. Let's understand why it is giving me an optimal answer if I assign upper to be the adjacent of first and upper to be the adjacent of last at the same time. Okay, so this is an upper and this is the upper at the last, and lower is in between them, 3, 4, 5, 6, 7. Okay, so if I apply adjacent to the first and adjacent to the last, now my count will reduce to 0. Okay, so now it gives me an optimal answer by reaching this index and by reaching this index. Now this index, this index. Now this index, this index. So I can assign this upper to be the first one and this one to be the last one. So that's why it gives me an optimal answer. Yes. What if my upper is odd? 5. What is happening here? Like my upper count value is 5. So I can assign 3 at the end, 3 at the end, 3 at the end, and 2 at the first. Okay. We can assign 3 at the first also and 2 at the end also. Okay. Yes, this is the optimal way to do it. But many of you wonder like why we are assigning half of the value to the first, half of the value to be the second, half of the value to be the last, half of the value to be the first. It is because if I reduce to the half and half value, it gives me an optimal answer to be the multiplied of. Like if you know the combinatorics concepts of competitive programming, you will know that if I multiply the smaller numbers, it will give me a better result in the end. Okay, so this is the lower value, lower values, and this is the upper values, half by half. Okay, so it will give me an optimal answer. Yes, that's the whole crux of this problem. Let me show you the code. It will be much better. Okay, so here it is my code. Okay, I will take input as n and string as s. Then I will count my upper values as a and lower values as b. Okay, so yes, I swap it because I did something wrong in this. Okay, so basically if we can't swap it, it gives me an optimal answer also. So if b is greater than or equal to 2 and a is greater than or equal to 1, then the answer is possible, otherwise answer is not possible. Okay, so at the first I will assign half of the value to be the part of first indexes and half of the values to be the last one. Okay, if my b is odd, then I will increment right by 1. Okay, yes, this is the concept. Okay, after that I will multiply left into a into right. Yes, it gives me an optimal answer. Yes, so this is the second problem of this contest. Now we are going to solve the third problem of this contest, and the problem name is creating keys for storages has become my main skill. Let me read the problem statement first. In this magical world, everything is different. For example, key for a storage is with the code n comma x is an array of length n such that now we are given two conditions, a1 or a2, where okay, okay, the max of whole array is being maximized and we are given n and x. Okay, we have to output n integers of ai in this range such that it fulfill two conditions. Okay, let me explain the problem statement further. Just copy this and paste it this. Okay, now we are given n and x. Okay, we have to find n elements of an array, like we have to find 5 integers of this array such that the OR of these element is equals to x, and maximum excluded element of this array is maximized. Okay, max is maximized. Okay, so this is the problem statement. I hope the problem statement is clear to everyone. Now we are going to move the solution. In order to solve this problem, we need to keep these two conditions in our mind. Okay, these two conditions. Let me just copy this and paste it here. Okay, let's suppose that we are given n and x. Okay, n is equals to 5 and x is equals to 7. Okay, so we have n is equals to 5. We have 5 blocks. We yes, 5 blocks. Okay, so we have to make OR of these elements is equals to 7, right? Yes. So let me express the 7 in our binary form. 7 in binary form is 1, 1 and 1. Okay. Yes. So let me think of a OR rule. OR rule. In our OR rule, if some bit is set, then all the remaining bit is set. What I'm trying to say is, let me just take some few examples. Okay, 0 0 1 0. Okay, 0 1 0 0 0, and this is 1 0 1 0, 0 1, this is 0 0. Okay, if I take the OR of these elements, what would be my answer? See, if I take, if I set this element, if the bit is one of the bit is set, okay, then the all in, then in our answer this bit is also set. Yes, this is the OR rule. Okay, if this bit is set, then in our final bit is also set. Like now in this case, yes, in this case no bit is set. Okay, so it will keep remain as 0. Now in this one bit is also set, so in our final answer the bit is set. Okay, so here is also one bit is set, so yes, this is our final answer if I take this OR. So we will try to use this concept in our answer. Now 7 binary form is 1 1 1, 0 1 and 2. Now we can select elements such that the 0th bit have 1 and first bit have 1 and second bit have also 1. Okay, so let me write what I can choose. Okay, so I can choose 1 1 1, 1 0 1. Okay, so 0 1, let me write in a sequence, 0 0 0, 0 0 1. Okay, 0 1 0 and 0 1 1, 1 0 0, 1 uh, 1 1 1 1 0. Okay, so basically it means that we can select an element if it is 1 here. Okay, if it is 1 at the 0th bit, then I can choose any element such that the element have the 0th bit also set. Okay, so now this is right. Okay, this is right. So what is the optimal way to select these elements such that the OR of whole array becomes 7 and minimum excluded element of whole array is maximized? Okay, so what is minimum excluded element? Let's suppose array is this 0 1. So minimum excluded element is 2 because 0 is present, 1 is present, 2 is not present. So our answer is 2. Okay. So what is the minimum excluded element of this array? Minimum excluded element of this array is 1 because 0 is present, 2 is present, but 1 is not present. So 1 is our answer. Okay. So so we have to choose, so we have to choose 0 till nth nth array, nth number, so we can maximize the max and it gives the 7 as the OR of whole array. Okay, let me change the color and try to explain it more. Okay, so our goal is to make the answer 7 1 1 1. Okay, so I can select 0. Yes, I can select 0. I have 5 dashes. Yes. N is equals to 5 and k is equals to 7. X is equals to 7. Okay. So I can select 0. Yes, I can select 0. Okay. So I can select 1. Yes, I can select 1 because 0 1 0 and this bit is set in our answer. This bit is also set. So I can select 1. So yes, this is basically 2. Sorry. Yes, I can select 2 and 1 also. 0, 0, 1. This is 1. And 0th bit is set in our answer. 0th bit is also set. So I can choose 0, 1, 2. Okay. So let's see our answer is 3. Yes, this is 3. Set, 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 set. Okay. So I can choose 3 in this position. So this is the last position remaining. Okay. So what is the answer of this whole array? If I take OR of these elements, the answer it gives me only 3. But our goal is to make the OR of whole array is equals to 7. So what is the remaining part? Okay. So 1, 1, 1 is our need. We have successfully covered the 3. This is our need 7. Okay. So this is 0. So we only need one bit set here. Okay. So yes, 1, 0, 0. So 1, 0, 0 is basically the 4. Yes. So I can choose 4 here. Yes. This is our optimal answer for this test case because it gives me minimum excluded element. Okay. And the OR of whole this array is equals to 7. So yes, this is the whole crux of this problem. It will be more clear if I show you my direct code. Okay. So where is the problem? I guess this is a contest. So problem number 3. Yes. Just a second. Okay. Yes. If if n is equals to 1, then I can simply return k. Yes, this much is clear because the OR of element is its own answer. Yes. Okay. So then I will create a vector and push back 0. I will push back 0 because 0 doesn't change anything in our answer. It will only contribute to our answer. That's why I am adding 0 at the first because n is equals to 1 is clear. So we have two numbers. So my answer would start from n is equals to 2. Okay. So one of them is 0. Okay. Rest of them I am building. Let's see. I will iterate from 1 till n and then I go from this rule. Okay. Let me explain this. In this, I am checking basically for I is equals to 1 till n. Till n. For all numbers from 1 till n, let's say my ith is 5. I is equals to 5. Okay. And my answer and my required k is equals to 7. Yes. K is equals to 7. Yes. So 1, 0, 1 is our 5. 1, 1, 1 is 7. Okay. So I check if this bit is set and this bit is set, then I will continue. Okay. If this bit is 0 and this bit is set, this will also continue. Okay. If this bit is set, this bit is set, then I will continue. It means that I can choose this element because this element is set and my required answer is also set. Yes. So that's why I'm considering this element. Okay. If let's say this situation is like this 0, 0, 1. Okay. My required answer is 0, 0, 1 and my I is equals to 4, which is in our binary form. Okay. So in our 4, this bit is set, but in our required answer, this bit is not set. So we will not choose this element. Okay. I hope this much is clear. Yes. So that's why I'm checking this. If this is set, yes, if this is just set and in our required answer, this is not set. Yes. Okay. So I will mark flag is equals to false and break out of the loop. Okay. If my flag is true, then I will push back my answer. Okay. So otherwise, else break. Okay. So yes. If my if all the elements have been occurred, okay, so all the remaining elements I will push 0. Okay. Otherwise I will check if the OR of whole array is not equal to k, then I will simply pop back and push back k. I will explain what this it means. Okay. So let's suppose that these are my elements a b c d f. Okay, these are my dashes. If let's say I am building this solution is equals to k. These four elements give me the OR value is equals to k. So I will put 0 at the remaining places. Okay. This is, yes, this is it. Okay. So yes, if my OR is not equal to k, let's say I am building this, and if I choose all these elements 0, 1, 2, 3, 4, 5 for these places, and my answer is still not getting is equals to 7, or otherwise let's say 45 or anything. If my answer is not equal to 45 or anything, then I can simply pop back the last element and push the this element into this. It will give me a uh, OR of whole array is equals to 45. Yes, that's the key. If my OR is not equal to k, then I will simply pop back and push back the value k. Then I will print the answer. Yes, this is the whole crux of this problem. Okay, I hope the problem statement and solution is clear to everyone. Now we are going to solve the fourth problem of this contest, and the problem name is for wizards the exam is easy but I couldn't handle it. Yes, let me read the problem statement first. Okay, so he was given an array of length n. He needed to minimize the number of inversion in the array after applying the spell exactly once. Okay, the spell was simple to apply. Akito had to choose two numbers L and R such that yes, L and R in this range. So perform a cyclic shift of the subarray from L to R one position to the left. Okay, so this is our operation. We can choose L and R and going to left. Okay, so let me explain the problem statement more clearly. Yes, so yes, okay, so we have our goal is to minimize the number of inversions. So what is the inversions? Like if I choose this element, okay, so uh, if I choose this element, the number of elements in this range, it is if it is greater than 3, then we will count how many numbers are greater than or greater than 3 from 0 till n minus 1, n minus 2. Okay. Yes. For 3, 5 is bigger, 4 is bigger. So the value is equals to 2. For 3, 5 is bigger, 4 is bigger. So our value is 2. Okay. So for 5, since 5 it is a greatest element, so no one is greater behind it. So it will remain as 0. So 2, it will 3 and 4. Uh, 2. For 3 it is 1. 4 is equals to 0. 1 is equals to 0. So our answer is the sum of this array. Sum of this array. 1 plus 2 plus 2 plus 2. Okay. 2, 4, 6, 7. So the minimum, so the number of inversion in this array is 7. Our goal is to minimize this. Okay. By uh, by applying the operation exactly once. Okay. So what is the operation? We can select L and R. Okay. If I choose, let me just erase this. Okay. Yes. I can choose L and R. Okay. And cyclic left shift to it. Okay. It means that I can shift this this array to be the left. Okay. So my 2 becomes 5, 3, 3 and 3. Now my array will become like this. Okay, so this is the operation. Our goal is to minimize the number of operations. So I hope the problem statement is clear to everyone. Now we will move forward to our solution. If we see carefully of our constraints, n is 2000 and a of I is also 2000. So it means I can apply a solution which gives me a big O of n square time complexity. Okay, yes, I can apply a solution which which gives me time complexity of big of n square. Okay, so yes, we can do brute forcefully, right? Yes. So my approach is to do basically brute forcefully in this problem. This is the much easier problem than the third. Okay. Yes. So we can select every sub array. We can select every sub array. Select every sub array and calculates its uh, inversion value. Okay. Just give me a second. Yes. A B C D E F G H I J. Okay. If I have to minimize the inversion of this array, let's say these are my array elements. Okay. So I will calculate which sub array gives me the most inversion value. What I am trying to say is, like, I figured it out for this array, it gives me a minimum inversion value with 6. So it gives me a 7 and it gives me 9 like this. Okay. So I will calculate which sub array would give me a maximum inversion value. The array which will give me a maximum inversion value, I can select those sub array and move it to the and apply the operation exactly once. Okay, so it will optimally give me the minimum number of inversion in this array. So I don't think I have to explain further more in this problem because it is much clear to everyone. Okay, so yeah. Okay, let me show you the code. Okay, yeah, the code for this problem is yes. I will take a input n and v vector. So I will run a loop from 0 till n, and this is a nested for loops. We can use it because our constraint is very low. Okay, so I will run a loop from j is equals to I plus 1 till n. Okay, if v of j is less than element, okay, so I declare element is equals to v of I. Basically, I mean this is our I pointer, this is our j pointer. Let me change the color. J pointer, this is I pointer. Okay, if my j value is less than, if my v of j is less than element, okay, I will increment element. I will increment the count value, otherwise I will decrement the count value. Okay, if my count is greater than our max value, then I will take L is equals to I and R is equals to J. Okay, so yes, that's it guys. So L plus 1, R plus 1 because of the one base indexing. Yes, this is the solution to the D problem. Okay, so yeah, this problem is easier than the third problem. Okay, I guess. So now we are going to solve our the last problem of the contest. Okay, and the problem name is, do you love your hero and his two hit multi-target attacks? Okay, So this is the very interesting problem and it is totally based upon the math. Okay, so let me read the problem statement. For the spell, Kaito needs to place n till 500 staffs at distinct integer coordinates. Okay, so that there will be exactly k pairs of I and j such that delta of ij is equals to d of ij. Okay, yes. So our constraint is n is equals to 500 and we can assign xi and yi minus 10 is to power 9 till 10 is to power 9. Okay. So let me just copy this and paste it here. Okay. So yeah. So our problem statement saying is that this is our coordinate system. Okay. So we have to place some number of points. Let's say this is a point. Okay. This is a point and this is a point. This is a point. Okay. We have to place these points such that in these points the number of pairs satisfy the condition delta of a comma b is equals to d of a comma b, right? Yes, we have to find the number of points such that the pairs of numbers is equals to delta of a comma b is equals to d of a comma b. Okay, so I guess I hope the problem statement is clear to everyone. So let's move to the solution. Okay, so let me just erase this. Yes, 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 yes. Okay. Okay, so let's just solve these first two equations. Okay, so delta of a comma b is equals to d of a comma b. We need these to be equal. Okay, first I will solve this equation. Okay, so let me just write this. Okay, so I can copy this. Uh, yes, so we have to make this and make this equal. Okay, so let me just write this. Our delta p of a comma b d of a comma b. Okay, yes, we want this to be equal. Let me just write this. X1 minus x2 whole square. Okay, so plus y1 minus k y2 whole square is equals to x1 minus k x2 mod plus y1 minus k y2 mod, right? Okay, so let me squaring both sides. We will squaring both sides. Okay, yes, if I'm squaring both sides, this square will be cut with this under root. Okay, so our in this our left with x1 minus x2 square plus y1 minus y2 square. Okay, so if I open this square, it will become x1 minus x2 square. Okay, plus y1 minus y2 square. Okay, so plus 2 into x1 minus x2 and y1 minus y2, right? Okay, so now x1 minus x2 square whole square can cut with this. Okay, y1 minus y2 whole square is cut with this. Okay, so I will left with 0 is equals to 2 into x1 minus x2 y1 minus y2. Yes, these two will become 0 and I will left with x1 minus x2 and y1 minus y2. Okay, so I can equate both equation to be the like this: x1 minus x2 is equals to 0, and y1 minus y2 is equals to 0. Okay, so now x1 is equals to x2 and y1 is to y2. Yes. So now our problem statement or answer boils down to these two equations. Okay, right? Let me just this make it bigger. Okay, so this is our main part. This helps to solve this problem. Okay, so now if I have to make equal to k pairs, like I have to select some points that will make up pairs equal to k. Okay, so either x1 is equals to x2 or either y1 is equals to y2. Yes, either x1 is equals to x2 or either y1 is equals to y2, but not both at the same time. Yes. Why? Because it will violate the distinct integer coordinates condition. Okay. So yes, either x1 is equals to x2 or either y1 is equals to y2. Okay. Let me show you the coordinates. Okay. So if my n is equals to 2, uh, either I can select x1, x1 is equals to x2. Okay. Yes. Okay. Now x1 is equals to x2. I can choose any number from 1 till 500 for the y part. Okay. Like I can choose x is 1, x is equals to x2 is equals to 1. Okay. So now my 1 is this. Okay. So let me just reverse this. Okay. Yes. So this is the y part basically. If my y1 is equals to y2 is equals to 1. Okay, so I can choose x x x value to be the 1 to 100. Okay, so yes, same for the x part. Yes, so I think this much is clear to everyone. Okay, so now for the final solution. Okay, we have to make the k pairs, right? Okay, so how we can make the pair? Of course, n into n plus 1 by 2, right? Yes. Okay. So for we know x1 is equals to x2. We know x1 is equals to x2 or either y1 is equals to y2. Okay. So for x is equals to 1, I am trying to find the maximum pairs I can form with this till the 500. Okay. It means that I can select pairs like this. So I will try to make the pairs like for one, uh, like we have to express in the form of n comma 2, n comma 1. Okay, like we have to make the like this n comma c1. Okay, n comma c2 plus n comma c3 is equals to k. Okay, so yeah, this is it basically. uh, like for the n part, uh, for for choosing one, we can select how many uh, distinct elements I can choose. This is the y, basically this is y, this is x. Okay, if I choose x to be the one, okay, c is equals to 1, then I have to determine what is the maximum value of y I can choose. Okay, so k is basically nothing but this is a sum of nc1, nc2, nc3, all that. Okay, so it will be much clear if I directly show you the code. Okay, coding part. So this is my where is this go? This is my code. We will take k. Okay, and we will store in our answer. Okay, while k is not equal to 0 and current is equals to 2. Basically, I'm trying to find the maximum pairs till k is less than till my current is less than k. Okay, basically this is my pairs. Okay, I can form. So yeah, yes, for current, I will push back y plus. This is basically k is nothing but my sum of NC1s. NC1, NC2, NC3, yes, like this. So I'm trying to find the n here. I'm trying to find the n here. Current is basically the n here. Okay. So yeah, yes, y plus plus. Then we will do y plus plus, and yeah, x plus plus. Then I will subtract k minus the current total number of pairs I have formed. Okay, so yes, then I will continue the loop till k is not equal to 0. Then I will print the size of answer and elements of and the uh, coordinates of points in our answer. Okay, so I think this is it. This is the E problem. Okay. So today we have solved the 5 problems of the Codeforces round 1006 division 3. So thank you very much guys.